Today we are doing a problem binary subarrays with some given binary and in the return number of non-empty subarrays with some goal. Subarray is a contiguous part of the array. Okay, I mean that's quite easy. We do sliding window. Like, okay, from this position we move the goalpost. We will have one right pointer for the first time we get to the goal, and then another until here, and we subtract that, right? And then when we move here, then we immediately move here, and then the other pointer should move too, I guess. So I mean, we could just brain that binary search in N again, but not sure I wanna do that. Okay, let's try this. So I mean, the force of N log N would pass, but so number of subarrays can be n times n minus 1 divided by 2. So L R1 R2 okay, and now while what? While L is under N, L plus plus in each iteration. Now what do we do? Well, count is 0, so while count smaller than goal, then count plus equals nums R1 plus plus. This is crazy formula, but we want to, there is binary, so who cares? And then so R1 n this if R1 n ends on the goal break, right? Otherwise R2 R1 while R2n ends on goal no. And nums R2 plus plus, and then ans plus equals long R2 minus R1. Okay, that's weird. Because I'm not updating this, so count minus equals nums L. Okay, now there is too few. That's great. If R1L R1 plus plus. Okay, now this doesn't pass. 0, 0, 1, 2, 3, 4. That's fair. And then when I move 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. Always problems with this type of shit. Not sure if I have time or energy to deal with. Okay, let's try a different approach. L1, L2, R. return 0 subarrays if not met. And now what we want to do. Now while summed over goal, okay, it's late and I should have done the binary search from the start. I'm already cooked with tomorrow's work. I'll do the binary search on prefix sums and that's it. Okay. What if pref I plus 1 minus pref m? So first I want lower bound, so the last position that this holds. So if it's larger than or equal to goal, then we want to update. Otherwise, if it's smaller, then we do that. So that's like int L1 is L. Ri, I guess, and then M is if pref I plus 1 minus pref M is what do I want? So if it's smaller, no wait, I want the last position where this holds. So if we have less, then I want to shift there, but wait, so if it's more, then I want to do n plus 1. Okay. And finally, I want upper bound, so if it's a maybe, not really. Long. So what I want, upper bound, so if, okay, that's fair. But if 1 minus pref L plus 1. It's a bigger one. Pref L. Fair enough. Okay, I mean you could do linear time, but I really cannot do that. For each, let's find all subarrays with some goal ending at position R. Do this by finding the first position L1 such that sum nums L R goal last position L2 such that sum nums LR goal L2 L1 and the number of subarrays ending at R with some goal is L2 minus L1 plus 1, maybe, I don't know. And then okay, we can how to find these positions. Notice that L1 and L2 for each R create non-decreasing sequences. Therefore, we can either binary search for them over prefix sums or use 2 pointers. In Leetcode, I did 2 pointers since the binary search option, which has a time of space complexity of ON. So time complex is on if we use the 2 pointers approach, since both pointers, since all pointers will go through all positions once, and we do constant work for all combinations of O of 1, since we only need a couple of extra variables for the pointers themselves and cumulative sum in the windows. Okay. Goodbye.